Waves and Radiation, Lesson 13, Light and Reflection. Lesson 13, Light and Reflection. We look at how light is a wave and transfers energy, how we use light to see objects, and how light has different properties including reflection and refraction. Our experience and outcome is by exploring reflections, I can use my knowledge of properties of light to show how it can be used. Now this is a second level outcome, so some of you may have used this in primary school. If we have a look at our success criteria, I can state that light is a wave. I can draw a diagram to show how light is reflected from different shapes of mirror, and I can predict the path of reflected light from a surface. Interesting fact, light is part of the electromagnetic spectrum and travels at 3 × 10⁸ meters per second. That's 300 million meters every second. Written out in full, that's a 3 with 8 zeros behind it. Nothing known to mankind can travel faster, not even Usain Bolt. Interesting fact number 2, light from the sun takes 8 minutes to travel to Earth, and that's even though it's traveling at the fastest thing known. Let's have a look at the direction of light. Light causes shadows because light travels in straight lines, and they don't go around corners. In class, we would have a look at a demonstration done by your teacher using a Raybox kit, where we can summarize what we would see. The first activity is looking at the reflection of light. We would look at this diagram and complete the diagram to show how light is reflected from a plane mirror, that is a flat mirror. On the diagram, we can see we've got the mirror at the top, and then we draw this line at 90 degrees, right angles, called the normal. We then have incident rays going onto the surface, a red one and a blue one, and they're at different angles of incidence, that is angles from the normal. We're going to use our analysis skill to find out what happens. In a second experiment, we have a look at the reflection of light coming from curved mirrors. A convex mirror that curves out, and a concave mirror, so called because it caves in. Notice in this experiment, we used 3 rays of light as opposed to a single ray of light. We can see that light enters, and on the convex mirror, it's reflected out. On the concave mirror, it's reflected in and comes to a focus point. We can summarize the results of the experiment by looking at this summary. In reflection, when light is reflected from a plane mirror, the angle that it creates with the normal is the same as the angle we would see with the ray that's reflected. And actually this law of reflection is used in pool when you're trying to hit a ball off a cushion in order to get it in a pocket. In physics, we say the angle of incidence, I, is equal to the angle of reflection, R. And we explore this much further in National 5 Physics and in 3rd year. For the curved reflector, we can see for the concave mirror, light is reflected into a point, into a focus. So this is the same way the satellite dishes work. They collect signals from space, and then those signals are concentrated to a central point where you could maybe have an aerial, which is why they're sometimes called dish aerials. A convex mirror you might have seen within a small shop. They're used to spread the light out so people within the shop can see all around the shop and check for shoplifters. So let's go back to our success criteria. Can you state that light is a wave? Draw a diagram to show how light is reflected from different shapes of mirror and predict the path of reflected light from a surface. We're going to check the application of your knowledge in an unfamiliar situation by the show me questions. The question will come up. You can pause the video and then you will see the answer. Light is a wave. Light is reflected from a mirrored surface. Here's a diagram showing two incident rays onto a plane mirror. You're asked to draw a diagram showing the angle of reflection for both the incident ray 1 and ray 2. And this is what we would see. We would see the two lines reflected as a mirror image of each other, where the angle of incidence for each of the colors of light are the same. This angle matches with this angle. This angle matches with this angle. And that's because I, the angle of incidence, is equal to R, the angle of reflection. Here we have a concave mirror with three parallel lines of light going in. You need to draw what would look like when this goes into the mirror. We can see that the rays of light are reflected and come to a focus point in front of the mirror. And that is how we would use satellite dishes. When we look at the similar rays going into a convex mirror, we see the light being spread out.